Hi, this is Merlin too. I'm just gonna talk about what I learned today. Actually, I'm reading some kind of research paper which is kind of like about MIFC, MIPS, which is kind of uh, RI risk architecture. But the reason I have to learn about this thing is because I have a computer architecture my class, so I'm forcing myself to study it. But actually, because the reason why I don't prefer some kind of risk kind of thing is actually nowadays we are commonly using ARM x86. X86 are they use CISC, so I don't know why I have to learn about some kind of risk, but I don't get it. So, but let's just skip it. But there's even though it's not practical, there's something able to learn. So the risk is just the reduced instructions. In low level language like assembly, the instructions is really important. So what do you mean by that? Like CISC, they using some kind of complex instruction. Example, um, you're doing some kind of like move, like here if you look at like this part rep moves. So there's like repeat move instruction. It's just like moving. It's just like like adding some kind of data to the memory, but with a for loop. So that's kind of simple. That's kind of like even understandable inside C, but like x86 they just use the one instructions of it, one opcode rep and moves are gonna be the target of it. But the problem is that the risk in the risk perspective in this thing is they parse it, not they parse it, they break down into some kind of some kind of actions. Example, if you look at like C here, like for loop, like adding some kind of data to the some kind of specific array. But in this moment, you have to create some for loop, and you have to like care about the addresses, and you have to care about some kind of which data has to be merged, has to be in the target memory address. So that's kind of really um, that's kind of really the rep moves is actually simplified version, but it requires the more instructions of it. um, and the risk is just break down into this kind of complex instruction and just trash the order unnecessary thing is, and they just use it as a possible. So that's kind of risk thing is, but if you're like engineer, software engineer, you're able to learn that it's kind of really similar to high level language like given to front end engineers, because like example the JavaScript, if you just use JavaScript just build some kind of application, you will be able to learn just simple application, not that really big is. The thing is that the size and the optimization is really faster than the one has used the Next.js framework or React library. So this kind of thing, because the more this kind of interesting part is because the more you have a dependency on it, more the dependency, the more you have the correlation between the others, um, it will eventually make some kind of the performance bad performance bad performance, because I mean like that is how it goes. This because if it is like if there's some kind of like the the relation between the modules are really heavily tied up, that means that you cannot easily optimize some kind of specific module of it. So because if you look at here like ISA, they use the micro, like I forgot it. They use a compression of it, but I forgot what it means. That yeah, diffuse. I think the micro, yeah, micro fusion. So this is kind of simplified version of it. So the more the dependency between the modules are are separated, the easy that you can put the some kind of optimization, and that's really valid in some kind of like even web development. So that's kind of really simple thing about this. The micro ops means that it's just like the breakdown. It's just the breakdowns of complex instructions, but into some kind of simpler instruction, but for the risk. But the and also the dynamic instructions counts means that it's very simple. So if you look at how really like computer architecture works, they just use the inside under the hood they use fetch, decode, execute cycle, and the dynamic instruction counts is the instruction who goes through the fetch instructions, fetch instruction, fetch, decode, execute cycle. So if the one instructions has has no issue going to this kind of fetch cycle, and you plus one to the dynamic instruction counts. So dynamic instruction counts also means that your instructions are fully executed by the processor. So that's how it goes. So, and also the dynamic instruction counts is really important because that can this factor can be compared into some kind of using based on their architecture risk assist. If you look at here, into some kind of limited instructions, the risk has able to build perform the task but written some kind of like 2%. It was like 6% of 2%, but of the x86 instructions. So they are doing a specific task of it, but instruction is there is doing those kind of same tasks with the x86, but really minimal instructions. But that's gonna be performance up of it. And also the ISA, and also the fetch. There's some kind of like fewer dynamic instruction bytes, and these terms really seems like really like complex. Like dynamic instruction byte, it sounds very complex, but the thing is that dynamic instruction bytes is just like the instruction bytes from the x86 counts, and the in the fetch cycle. So that's really how it goes. It's just really simple. It's just like how many bytes is being gonna use, because the size of the bytes is really important, because the instruction has to store in some kind of specific memory, and if the size is really huge, the memory, there's gonna be the more memory that you have to use. That means also you have to look for the other like memory pointer. So that's gonna be like really complex of it. So I think this is it. So actually, I don't know why I'm reading this kind of stuff, because I already have assignment today, and I don't know. I don't know what's gonna happen. If I wake up early, I'm just gonna do it. But if I wake up late, I can't do it. So have a nice day. See you next time. Bye bye.